Hello fellow YouTubers and 3D printing enthusiasts. Gotten a little further along here. I've got the covers made up here, magnets installed. All the pieces actually from here back are pretty much installed. This shaft here is temporarily installed into there, and there's some hex key screws in there, 2.5 millimeter nut that holds them. Last time I spoke, I said that there was a piece missing in the instructions. Actually, I found it later. It was step 4. And they had a little stubby input shaft. This would turn this counter shaft. The counter shaft goes through here. That gives you your low range gear. When shifted directly straight there, this gear here, low range gear, actually is on double bearings. Would not turn. This would just idle, spinning with this, but not be affixed to the shift coupler. So that would be shifted forward here, like that. And then when you are in low range, it'd be shifted like that, obviously. Here's our 4-wheel drive, 2-wheel drive shift. Obviously, again, this shift coupler would go forward, engaging the rest of these remaining gears. All right. Eric, the man who came up with the 3D print STL files for this motor and transmission. He's also does several other Volkswagen Beetle, flathead V8s. I believe he's done maybe an LS model. Anyway, you look him up on Thingiverse under the name, I believe, Eric the Pool Boy. And like I said, he's done several 3D printable engines and such. What I also wanted to talk about today, let's get back to this real quick. The stubby input shaft would not work with this because we still have to go from this low range gear reduction box to this low range gear reduction box. That, again, same identical parts, but what I had to do is I couldn't find, again, maybe I'm not reading the directions, but I couldn't find the length for a shaft that goes from here through into there. So what I decided to do is just assemble it, trial and error. So this shaft is pushed in, it stops at the other shaft, and you set your set screws. Goes through all your bearings that are in here in your adapter. And again, same part, and it would have to stop midway through this gear. Again, same thing, the same identical part, but it's got to stop midway through this gear. This gear is going to have a bearing, so this shaft will allow that bearing to ride, and there'll be another input shaft that'll be screwed in again with these Allen set screws. Of course, the real ones in the real transmission are splined shafts and couplers that go into there. But anyway, that's where I'm at with that. So now I've got my mark, so I can cut that to length. Also wanted to discuss failed prints. Don't be discouraged, guys. We've got some failed prints here. I've had hundreds, especially just 3D printed gears, that failed. They were failing. As it turned out, it wasn't my printer, it wasn't my print settings. On these, it was actually the computer. It had maybe a sleep mode, or it would generate the G file, but sending the G file to the printer, because it was a leased printer, Lulzbot Mini, not the Gen 2, but the Lulzbot Mini was a leased printer and had to be connected to the computer. For some reason, the computer just couldn't handle that, and it would cause failed prints. It would pause in the middle of that, and usually even leave a nice big glob of plastic where the printer nozzle would just sit there and ooze filament, and ooze filament until I would catch it. Here's another printing in ABS, and sometimes you get stuff like this little guy here where it curled up in the middle of printing, continued to do a nice job printing the rest of it, but you got that nice little curl where the layers are compressed and just not quite usable. I also have a TAS 5 with the Gen version 2 two-color print head there, or dual extruder. This failure, actually I figured out, it took me quite some time to figure out. I had a heating element and the thermocoupler. The thermocoupler was not working right. It would make enough heat to melt the plastic initially, you know, by reading things, and then as you'd go through the print, the readings that it would feed back to the printer would become wrong. Then the printer would no longer be melting the filament, and it would clog the print nozzle, and then strip out the filament there at the drive mechanism, and over and over and over and over and over again, you know, swapping filaments back and forth. I did have a bad spool of filament that just didn't want to melt at any decent heat range for some reason. It was an older one. It was one that the TAS 5 shipped with. Got that solved. Did manage to make some halfway decent keychains. Here's my latest. I'm trying to print a pedal stool for a 3D printable wind turbine off of Thingiverse again. But for some reason, I think this is over squish or maybe some other problems, over extrude. But we're having, basically it's printing wrinkled. It almost looks like an old record, but it's in white. You know, if you've ever had the old records where sometimes you'd get cheap records that may have came with a children's book or something, they were usually paper thin. You could almost see, you pretty much see daylight through them, and this just reminds me of those. I also changed the settings from concentric back to lines, and I am getting a much better print. I did spend some time trying to dial in the speed and temperature, as well as playing with the diameter settings, just so it wouldn't over extrude so much. So you can see we've got quite a bit of these boogers on there, and this is one of probably a dozen that were failed prints. So that's my side topic of the day: failed prints. Don't let them stop you. Keep on trying. Figure your way through them, and you'll eventually be very happy with your prints if you can solve those problems. But if anybody knows the real reason I'm having this problem, please message me. And that way I can continue on learning more about my 3D prints. Alright, I think that is all.